everyone, and welcome to the Kathy and Kevin Show. Today we have a very special guest, a good friend of mine, Gabe Santos, who is a National Geographic Grosvenor Teacher Fellow and also works in a paleontology museum. So Gabe is going to give us a tour of his museum. Gabe, what is paleontology?
Great question. So paleontology is the study of the history of life on Earth. Everything from the very, very first single cell organisms all the way to the end of the Ice Age and right about to the beginning of when humans start to appear. That's kind of what we consider all of the history of life on Earth for paleontology. We're basically storytellers of the past.
Got it. So I guess a lot of people think of paleontology as the study of dinosaurs.
That's what I think of. Dinosaurs.
It's partially true. Dinosaurs are a small part of that history of life on Earth. And, you know, dinosaurs are super cool. So everybody like really draws on them and like attaches and thinks like that's the only part of our past. But really, there's so many more cool animals that have existed before and after the dinosaurs. But that's a common thing that people just think paleontology is dinosaurs. And it's not technically wrong.
Got it. Okay. So a lot of the things that we're going to see today are not dinosaurs.
Correct. I'm going to show you some really cool stuff from millions and millions of years before dinosaurs. We do have dinosaurs for all of our dinosaur lovers out there, and then some mammals, and even a little bit of like how paleontology affects our world today.
Cool.
So I am here at the Alf Museum of Paleontology in Los Angeles, California. We are a small museum, but we have what we call a big heart. We are the only accredited museum on a high school campus. So we're very special in that we actually get to teach high school students about paleontology as well as the general public. Our museum was founded in 1932, but it was built in 1968. And since then, we've gone on hundreds of expeditions and found fossils from all over the world. But a lot of what we have is found right here in California.
And then in your museum, are all the specimens things that you guys have found?
For the most part, yeah. I would say like maybe 90% of our collection were collected by our museum paleontologists and our high school students. So right now we're going to do a tour of the Alf Museum. Right here, we're in the entrance to our museum. So I'll just show it around. We have these really cool 2 floors of exhibits here. But when you walk in, one of my favorite things to show is this. This is one of the first things you see when you walk in the Alf Museum. This is a huge slab of rock that has lots of these really cool footprints in it. And it goes all the way up to the ceiling.
That thing is huge.
That's awesome.
It's pretty huge. And the cool thing too about this is about 350 million years old. This is older than any dinosaur. So the footprints you see here weren't made by dinosaurs, but lots of other early reptiles that existed millions of years before any dinosaurs appeared. The reason this is my favorite is because, like we said earlier, when people think about paleontology, they only think about dinosaurs and they only think about bones. But when you're a paleontologist, what we do is we look at the evidence of past life in order to reconstruct the story of life on Earth. And any evidence of past life can be things like bones, yes, but they can also be things as simple as a footprint preserved in the sands of time, as our founder would say. They can be things like scratches or rocks that some animals ate. They can be something like fossilized poop even. Anything that shows us evidence of life, anything that existed millions of years before that was preserved in the fossil record can be used by paleontologists to tell this story. And so here with this giant track slab, we have an amazing story that as paleontologists, we have to find this evidence and tell it. So if we look, right, we've got all these little footprints, but as a paleontologist, we have to step back and be like, what direction are these footprints moving? Are there different sizes of footprints? What does that tell us? It tells us that there are lots of different animals living together. Some animals were faster based on the distance of the footprints. Some were a lot slower because they were moving at a slower pace based on the size or the distance between their footprints. Some animals, right? Like if you look at these really, really tiny ones, weren't even lizards at all. Some of these were insects. We also have things like animals fighting, as you can see in this kind of weird disturbance over here. And so as a paleontologist, we love to see these kind of things and hope to show other people who aren't paleontologists that every single piece of evidence from the past is a wonderful, beautiful moment preserved in time.
I assume that it must have been a pretty wet area at the time to make those footprints that deep. So
you would think, right? But
yeah.
actually, these footprints were made in what we call an aeolian environment. These were ancient sand dunes. And so what happened is on these ancient sand dunes, early in the morning, when a little bit of mist and dew was right on the top of the surface of it, these creatures walked along the surface, made these footprints, but as the day got warmer and the wind picked up, it would blow sand on top of it. And then it preserved these footprints in a very actually dry, sandy, windy environment. This was not a muddy environment.
But usually when those winds blow, it blows the tracks away rather than covering them and preserving them. So what was it about that specific time that made it so that they were preserved?
So when things fossilize, whether it's a footprint or a bone, it's usually a very, very rare event. It needs a very special set of circumstances. For this one, before these were buried, the sand and the dew or the water that was covering it had to be just enough for the footprints to sink in deep enough and hold its shape. Then immediately after, the sand needed to come and cover it just enough so that when the wind blew, it wouldn't blow away the footprints. It was protected under that. And then they needed to dry really, really fast. So a number of circumstances, like series events had to happen for these to happen. It doesn't happen all the time. It's very, very rare. So today you may see footprints, but those may never become fossilized.
So that's why I guess you know for a fact that all of that stuff happened probably in the course of one night.
Yeah.
Rather than like, this happened 2 weeks before the next one.
Yeah. It needed to happen really fast in order for them to preserve.
Wow, so that's a lot of animals in one night.
Right?
That's so cool.
That's probably
a fun fact too about this is that we actually had to lower it through the roof before we built the roof on the museum because it's so big.
Where is it from?
This is from Arizona, the Coconino Sandstone.
Wow, that is so cool.
Is it like a thick rock or is it really like fragile?
It's a thick slab.
Yeah. Oh.
So this weighs a lot.
What would have been under it? So like, why is it that part is like that thickness, and then there has to have been something underneath it and something above it, right? Like.
Yeah. So I think I can illustrate that better here in our rock wall. So in geology, we have this thing called stratigraphy. Basically what happens is over time, layers and layers of sand and stone accumulate on top of each other. Like I said before, these are different chapters in time. Each layer has different types that make it up. So some is more sandy, some are more rocky with larger pebbles, some are made of like things like limestone. And in between these different layers, because they're not quite the same, right? They don't necessarily stick as well together. There's kind of like that little line here where they're not the same. They're just able to break a little bit easier. So in fossilization on that footprint, above it, right, we had the trackways and above it was the sand that covered it. Because this part was really wet and there were the footprints in it, the sand above it was a little bit drier. They didn't quite stick together as well. And that lasted even after it lithified. So there's this plane of weakness along these lines that allows it to like kind of flake off easier. Sometimes these layers can be thick. They can be really huge. And sometimes they're tiny, tiny, thin layers. It all depends on the environment where these layers of rock were formed. You can kind of see it a little bit better too here. If I show you this, you can see all these different layers of rock and each one is different. And you can see those different lines there that separate them out.
Are fossils always found between the layers, or are they sometimes buried in the middle of layers?
Fossils are found usually in the layer itself. The difference between the different layers tells us the separation of time. So this is one period of time, and this is another period of time. And so when we find fossils in between or in those layers, that kind of helps us to learn how old they are. So here in our museum, what we did is actually we created our museum in a timeline. You go through time and you see older fossils, and as we move through it, we see different younger fossils. And we also get to see how things evolved over time, because that's a major part of paleontology, is understanding evolution. And here's a great example to show you how we kind of understand that in our museum. So here, let me back up a little bit. Here you've got 1, 2, 3, 4 different types of animals. Very, very different looking, right? You've got this tiny little one over here, and then over here you've got this big one. But in reality, these are all horses, just at different stages of time. We start over here.
That little
Yeah.
tiny, the horse?
Yep. That's a little tiny horse. That's a horse. That's a horse. And this is a modern day horse.
What?
These are all just different stages of horses through evolutionary time.
So horses used to be the size of cats, huh? That's interesting.
Yeah. About the size of a large cat.
How old is that, the cat horse?
So this is Hyracotherium, or Eohippus. This is about 55 million years old. This is one of the first fossil evidence of early horses found. A cool thing too is that horses first evolved in North America and spread out through the rest of the world. And what's also cool is horses originally had lots of toes. This horse had about 4 toes. And over time, as grasslands evolved and they started moving out of the forest, they started to lose or fuse their toes together. And so they went from 4 to 3 to standing on 1 with 2 extra toes, just having 1 toe.
Wow.
So I can't get a mini 4-footed cat horse for a pet?
Unfortunately, no. I would love to have one, but not anymore. You can have its descendants, the really, really big modern day horse. So as we go through time, we'll be able to see how animals change over the millennia. Here we have our very, very first chapter in the history of life on Earth, the Precambrian. This is from 4.6 billion years ago to 542 million years ago. And for the majority of this time, there was no life on Earth. For about 2 billion years, nothing was living on Earth. But then something happened 2 billion years ago. Some of the very, very first single-cell organisms appeared. We don't know what caused them to appear. Paleontologists are still trying to figure out what conditions led to all these proteins and molecules combining together to create these very, very first single-cell organisms in the fossil record. But what we do know is that they did exist, and that these very first single-cell organisms are what changed the planet and made it so that other organisms could exist and evolve through time. And what's cool also is that some of these descendants of these single-cell organisms are still around today. If you look at this picture here, it looks like it's just a bunch of rocks, right? Kind of down here, we've got these 3 big looking rocks. But really what these are a type of colony of single-cell organisms called stromatolites. Now, stromatolites are these layers of single-cell organisms that just build up over time, eventually creating these large columns of rock. And we find fossil evidence of these millions and millions of years ago. This one is actually 1.2 billion years old. That's a really old fossil. This behind me is not a painting or a reconstruction. This is a picture taken from Australia not too long ago in Shark Bay. Shark Bay is very, very hot. The water is super, super salty, and not really many other animals can exist in there. But it's the perfect conditions for stromatolites, for these colonies of single-cell organisms to grow. And another reason is because it's very similar to what Earth was like 1.2 billion years ago. It was very hot. The water was very salty and acidic. Not a great place for living and evolution for other animals. But then something changed. The Earth went from something that was kind of inhospitable, lots of volcanism, not a lot of safe waters. The sky was kind of poisonous for most creatures. But then the single-cell organisms started to change everything. They started to make the water less salty and acidic. They started to produce oxygen, which was essential for the evolution of life. And this explosion happened in what we call the Paleozoic, 542 to 251 million years ago, when these multicellular organisms started to appear, these complex animals with different parts and different parts in feeding strategies to kind of take over the world. So one of the very cool first fossils we find in the fossil record are these. These are called trilobites. These are early relatives of roly-polies, crabs, lobsters, any kind of insect. And they used to crawl the seafloor during the Paleozoic. They had lots of different sizes and shapes too. You've got this huge one. Some of the biggest ones were about 3 feet long. You've got little tiny ones with lots of little spikes and horns on it. You got ones that all live together. You can see these. But these are some of the really cool first fossils we find. And from here, things really take off. Lots of different types of organisms appear during the Paleozoic. Over here are some of my favorite fossils, actually. They're called crinoids, and they're relatives of sea stars and sea urchins. So this is kind of like their neck. This is their head. They had their mouth in the center, and these long arms, these were used for filtering food out of the water, and they put it into their mouth in the center. So these are actually a kind of animal, and crinoids are super cool because even though they appeared about 500 million years ago, they are still around today. You can still find them in the deep ocean, and they survived many mass extinctions. So these are some real survivors and really, really cool fossils. Some fish really, really took off and kind of did a weird experiment that we should be very, very thankful for. This here is a fossil called Tiktaalik. Tiktaalik is our great, 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 great grandmother fish. This fish started to adapt to land. Basically, land was vacant at this time. Nothing was living on land except for plants. And so some animals started to move closer and closer to land because it was open in an area where they could feed or exist without threat of getting eaten. And so Tiktaalik, its fins started to adapt to support its weight out of the water. And so this is one of the very first earliest evidence of creatures called tetrapods. Tetrapod means 4 feet or 4 limbs, and we are a tetrapod. So Tiktaalik is our ancient ancestor, and because this ancient fish started to adapt and go on land, we get to live on land today. So Tiktaalik is a very, very special fossil and a great example of how evolution can take these really weird turns, but turn out very, very important for lots of other descendants of it. So there's our really cool
ancestor of anything with 4 limbs.
Yes, it's kind of like a pre-amphibian. And from there, things like giant amphibians started to appear. These creatures were able to survive out of the water completely. They don't have fins anymore. They've got feet and limbs to support them. Some of them started to develop scales. Some developed sharp teeth and different skulls, like this one here. Some even started to develop these mammal-like structures, right? This is Dimetrodon. Now, Dimetrodon is really cool because it is an early relative of us, of mammals. These groups of animals started to go and develop hair, take care of their young, and were warm-blooded, unlike other reptiles. So this is a really, really cool fossil that shows our legacy. Those are some really cool animals. But here in the Paleozoic, you've got this huge explosion of different animals through time. You've got things taking over the land. You start to get big insects flying in the sky. You've got these huge, weird-looking amphibians. You start to see more insects, like this fossilized cockroach. You start to see all these plants.
That weird triangle thing, was that a skull?
Yeah, this is what some people call a boomerang amphibian. This is like this weird salamander-like animal that we call Diplocaulus. And so here's where its eyes were, and this were part of the skull, and its neck would attach here and come down. So this was the Paleozoic. This was a time of a lot of change and experimentation and evolution. But in the history of life on Earth, we've got these very terrible chapters, what we call mass extinctions. At the end of the Permian, we actually had this huge mass extinction and was actually probably one of the worst mass extinctions in the history of life on Earth. About 95% of all marine species and 70% of all terrestrial vertebrates disappeared at the end of the Permian. Something terrible happened there, and we're still trying to figure out, but a lot of paleontologists think that this A lot of volcanoes were starting to erupt. The climate changed very rapidly. Lots of changes in the environment happened that caused this huge mass extinction and the disappearance of all these animals. But luckily, not all things disappeared or went extinct. One special group of animals were able to survive this mass extinction because they had adapted to harsh environments and to survive things like that. And those were the reptiles. And those reptiles at the end of the Permian took over the land. And that led us to here, the Mesozoic, 251 million years ago to 65 million years ago. And a lot of people will call this the age of dinosaurs. I like to call it the age of reptiles, but I'll get into that in a second. But like I said, those ancient reptiles adapted and became some of the coolest, for many people, and biggest creatures to ever walk our earth. And those were the dinosaurs. So here we are now in our dinosaur section of the museum, and you can see a lot of really cool dinosaurs. This one here is actually my favorite. This is Pachycephalosaurus. Pachycephalosaurus is this really cool dinosaur, stood on two legs. And it's got this really crazy skull. You see all these really cool horns. And here is the thing that makes a Pachycephalosaurus a Pachycephalosaurus. It's this big dome skull at the top. Pachycephalosaurus means thick skull lizard, basically. And when paleontologists first discovered Pachycephalosaurus, they saw all these spikes in this huge head, and they're like, what was that for? Well, in today's modern world, we have animals with thick skulls and all these really weird horns, and they use them for fighting, for headbutting. Things like deer, ram, bison, they all fight using their big, thick skulls and their horns to protect their brain. And so when they found Pachycephalosaurus, because it kind of had those very similar adaptations, even though it's not a mammal, they hypothesized that it might have used its skull for fighting. Now, what happened is, as science got a little bit better, we had new techniques. Some paleontologists went in and looked at the thickness and the structure of the bone in the skull, and they found out that the skull actually wasn't thick enough and wasn't hard enough to protect the brain. So if Pachycephalosaur were actually headbutting, it might have led to a lot of damage to them, and they might not have been able to survive it as well as modern day mammals. So some paleontologists started to hypothesize that instead, all of this ornamentation, as we call it, these spikes, this big skull, was actually for attracting mates, finding a girlfriend. Kind of looks like a dragon, if you ask me. In fact, there was a species of Pachycephalosaur that was named Dracorex hogwartsia, which means the Dragon King of Hogwarts, because it looks so much like a dragon. This is the skull of a dinosaur called a hadrosaur. These were like the cows of the age of dinosaurs. They were super, super numerous. There were lots of them, large plant eaters that lived in big herds. And a lot of them were fossilized. We have lots and lots of evidence of these kinds of dinosaurs. And we know a lot more about them than we do, say, things like Allosaurus. Let's see. So let's move over here and let's show one of the most popular exhibits at our museum. This here is Velociraptor mongolensis. Now, anyone who's watched Jurassic Park will probably recognize this dinosaur. It's one of the more famous ones in Hollywood because it's starred in a lot of movies. And this one is very similar to the one you see in the movies. The one thing that, yeah, that's the one thing a lot of people realize when they walk over. It's too small, right? If I kind of turn my camera here and you kind of compare it with me, if you've seen the movie, it's not that big. And there's a reason for that. Whenever we see dinosaurs in movies or TV shows, sometimes they take a lot of creative license or artistic license when they're making them. You know, they're not exactly accurate because they have to look good or scary for the movie. Now, Velociraptor, in reality, is this big. It's only about the size of a large turkey, if you don't include that tail. 3 feet. So when they were creating the Jurassic Park movie, they're like, we need a scary, fast dinosaur. And so they found the name Velociraptor. That sounds so cool, especially in a movie. It sounds scary. It sounds cool. But then they found out how big it was. And they're like, that's not that scary. How are we going to have this small dinosaur be scary to all these people as they watch the movie. What they did then is they found another dinosaur called Deinonychus, which is a large raptor dinosaur related to Velociraptor. And they're found here in North America, and they're huge. They're 6 feet long. But then they realized Deinonychus is hard to say for some people and doesn't sound as cool. So what they did is they made it the size of a Deinonychus, but named it Velociraptor. And so the movie version we see is like a combination of 2 different animals for this really cool movie look. But in the real world, this is Velociraptor, and the bigger one would be Deinonychus. Another thing that we like to talk about here in our museum is that this Velociraptor is very scaly, right? Just like in the movie. But new evidence is actually showing us that Velociraptor is pretty much like a big bird.
That's
It's
scary.
feathered.
It's not looking scary.
I don't know. Have you ever been chased by a goose or a turkey? They're still
Yes.
pretty scary at that size.
That's true.
And imagine
And
something
teeth.
that big with that big claw chasing you still. I would still be afraid of this. But yeah, Velociraptor we now know is actually feathered. And this leads me to the next point. Because we have these amazing fossils of feathered dinosaurs, we also have these fossilized birds. And this evidence of fossilized feathers on bigger dinosaurs helped us to make the connection that birds are actually a dinosaur. So today, if you like eating chicken, if you like chicken nuggets, if you have turkey on Thanksgiving, that means you like eating dinosaur.
So what is it that makes a dinosaur a dinosaur?
That's actually a great question. So what makes a dinosaur is that they are all descendants of a very special group of reptiles. Things like this, Coelophysis. Now, if we look at the features of Coelophysis, they've got these front arms. They have these 2 legs that they could stand up on. They've got this special type of pelvis. These are the features that make a dinosaur and different from a reptile. Their pelvis lets their legs go directly under their body, unlike a crocodile or a turtle whose legs are spread out under their body, right? And that is one of the main things that makes a dinosaur is this set of features that lets their legs and arms be directly underneath their body. And also, this is what helped them to support their weight and grow into these huge, huge beasts. And dinosaurs are such a diverse group too. They had lots of different forms and shapes. Here we have the sauropods. These are the huge long-necked dinosaurs. And this is just one leg. You can see how high it is. It goes pretty much up to the ceiling. And this isn't even one of the biggest ones. Sometimes you had these these hadrosaurs, like I talked about earlier, which were the cows of the dinosaur age. You've got things like T-Rex. T-Rex is the tyrant lizard king, one of the more famous dinosaurs from the Cretaceous. A huge predatory dinosaur that stood on 2 legs. And then here you can see like Archaeopteryx, one of the earliest evidence of birds in the fossil record. So dinosaurs had a huge, huge range of shapes and sizes and adapted to all these different environments during the age of dinosaurs. But like I said, this is actually the age of reptiles because dinosaurs weren't the only reptiles existing during this time. Here, we have pterosaurs. Pterosaurs are these flying reptiles. And sometimes people think that pterosaurs are a type of dinosaur because they were found at the same time, but that's not true. They're their own group of reptile that evolved and adapted separately from dinosaurs. And they were some of the very first animals to fly. If we look up, we've got a fossil of one pterosaur here, Rhamphorhynchus. And what's cool about their wings from birds is that their wings are actually made from one single digit, kind of like their pinky. And it just grew really long, and they've got these membranes that attach, and that's what formed their wing. And so some were small, kind of like this, about the size of maybe an eagle or a falcon. And some were huge. This right here, that's one wing of a giant flying reptile called Quetzalcoatlus. If you put them together with 2 wings, it's about the size of a jet plane. When it stood up, it was the height of a giraffe, a real-life flying dragon that existed.
Wow.
That is incredible.
It's one of my favorite animals. To think about something like this flying in the sky, to think that like actual dragons once existed and hunted dinosaurs at one point.
Imagine a big flock of those. Yeah.
Yep.
And
And this is-
again, these are not dinosaurs. They evolved separately from those upright standing lizards, I guess.
Correct. Yeah, they're their own group of flying reptile. So the pterosaurs ruled the skies. The dinosaurs ruled the land. And actually, in the seas, we had our own other groups of marine reptiles not related to pterosaurs or dinosaurs. You had things like plesiosaurs, another group of marine reptile that adapted to living in the ocean. Their legs adapted to become powerful flippers. Their bodies became streamlined to help them swim through the water. Some were small, like this one, and others were huge. We had these groups of marine reptiles called ichthyosaurs. Their name literally means fish lizard. They adapted from reptiles that lived on land that looked somewhat like a lizard, and then their bodies ended up looking like fish or dolphins or sharks. Their bodies are streamlined. Their front legs became flippers, and their back legs became like flippers. And they actually developed a tail fluke, much like a shark. At 65 million years ago, something else happened, another extinction event. And so the dinosaurs, the pterosaurs, the marine reptiles, they all went extinct. But one group of animals were able to survive. In this T-Rex's mouth are these little things.
Squirrel.
They look like squirrels, right? These are ancient mammals, our ancient ancestors. These mammals were adapted to surviving these harsh environments because they're warm-blooded. They could survive colder environments. They could find food easier because they were small. They survived by going out at night. They were adapted to survive compared to these dinosaurs. And because of that, mammals filled the niche that the dinosaurs left behind. And we move into my favorite time period, the Cenozoic, 65 million years ago, all the way today. This is the age of mammals. And so those tiny ancient ancestors, mammals adapted to all these really cool forms, including the ones we see today. Here we go. Here are some really cool mammals that we have on display at our museum. This one is called Dinictus. Dinictus is a relative of cats, and it's kind of got like those saber teeth right here, you can kind of see. So this is an ancient relative of cats. So we've got Dinictus. Over here, we've got these cool animals that we call brontotheres. Brontothere means thunder beasts. And there are these huge animals, relatives of rhinos and horses. What's cool about them is they have got these horns on the tips of their noses, right? So people see these and they'll think, oh, they must be used for fighting, kind of like rhinos. But there's a big difference. Rhinos' horns are made of keratin, which is the same thing as our hair and fingernails, right? And it's not part of their skull. They can kind of break a little bit. There's no nerve endings in it. So those are more useful for fighting. But in brontotheres, these are actually parts of their skull. So they can't, if they break those, it hurts, right? They'll bleed. So they weren't using these for fighting. These were helping them to identify others of their species. And there are lots and lots of different types of brontotheres through the United States and Asia. And lots of other really cool mammals. We've got things like ancient camels. Now this camel was found actually here in California. And that's because camels first appeared in North America also and spread out through the rest of the world, to Asia, to Africa, to South America. And then they went extinct in North America at the end of the Ice Age. And only their descendants are left today. And this one, like I said, was found here, like about 2 hours away from my museum. You've got our Ice Age mammals over here. You got Smilodon, the saber-toothed cat. It's very popular. We have so many of these in California because of our La Brea tar pits. This is an Ice Age trap where animals would get stuck. And we have lots and lots of these cool animals to study and learn from. Mammoths, mastodons, early relatives of elephants that once roamed North America. Other groups of animals survived also. Things like Crocodiles.
Whoa.
Crocodiles are amazing survivors of time. They survive many mass extinction events and were able to adapt to all these different forms. This is a giant one called Prosaurus, which is no longer around today, but it's not even the biggest crocodilian to ever exist. The biggest one was Sarcosuchus that lived during the age of dinosaurs, but still pretty big and scary. So over here, we're coming near the end of the upstairs. These are the very most recent fossils we have in our museum. And these are the ancient fossils of our relative humans, leading all the way up to us, Homo sapien. I, unfortunately, have not studied human fossils, so I can't tell you too much about these. But this is one of the most recent chapters in the history of life on Earth, which includes the humans, as we adapted and changed over time. And no other creature has really changed the Earth as much as humans have. And so this is where we are today in our most current chapter with us. So that's kind of the story of the history of life on Earth, going through all those changes and different animals through time. Dinosaurs, yes, but lots of other things, turtles, crinoids, trilobites, mammals, so many things in our 2-3 billion years of life on Earth.
Well, thank you, Gabe. That was a really, really informative thing. And the idea of that giant wing that you have upstairs is frightening to me.
Thanks so much, Gabe. I really enjoyed it. I'm just disappointed I can't have a mini cat horse with 4 toes.
True. Thanks so much, Gabe. Bye.
You're welcome.
Bye.
Bye.